Section 12.3. Our objective today is I can find lateral area, total area, and volumes of right cylinders and right cones. So first of all, a cylinder is like a prism, except that the bases are circles instead of polygons. So you see here on the left, I have a cylinder whose bases are circles. The altitude is defined as the segment that joins the centers of the two bases. And the height, of course, is the length of the altitude. The radius of a cylinder is the radius of the base. Okay? And so the formulas then, the first one is the lateral area of a cylinder equals the circumference of the base times the height of the cylinder. So lateral area is 2 pi r times h. Okay, so that's the formula for lateral area. The total area of a cylinder is the lateral area plus twice the area of the base. Okay, so the total area is the lateral area plus twice the base area. Okay, so total area is lateral area plus 2 times the base. So remember, lateral area is 2 pi r times h, and the base is pi r squared, but we have two of them. So it's 2 pi r h plus 2 pi r squared. Okay, and the volume of a cylinder equals the area of the base times the height of the cylinder. So volume equals base area times height, or pi r squared times height. All right, so let's look at an example. So let's say I have this cylinder. Whose height is 8 centimeters and whose radius is 6 centimeters. Okay, so first of all, lateral area is 2 pi r times h. So 2 pi 6 times 8, or 96 pi centimeters squared. Total area is lateral area plus 2 times the base area. So 96 pi plus 2 pi r squared, which gives us 96 pi plus 72 pi, or 168 pi centimeters squared. And volume is pi r squared times h, or base area times height. So pi times 6 squared times 8. So we get 288 pi centimeters cubed. Remember that volume is always cubed. All right, so then that brings us to cones. Okay, so a cone is like a pyramid, except the base is a circle. Okay, so it would be something like this. Okay, and so we have, if we drop an altitude, okay, and so the segment joining the vertex of the cone to the center of the base is the altitude. So altitude is segment joining the vertex to the center of the base. Okay? And the height is the length of the altitude. Okay? But as with pyramids, we also have what's called the slant height. Okay? And the slant height is the hypotenuse of the right triangle formed by the altitude and the radius. Okay, and so that is the slant height. So if we pulled out that right triangle, this would be H, this would be R, and that would be L, the slant height. Okay? And here are the theorems for the formulas involved with pyramids. So first of all, the lateral, Right, cones. A cone is like a pyramid, except for the base is a circle. The altitude is the segment joining the vertex to the center of the base. The slant height is the hypotenuse of the right triangle formed by the altitude and the radius. And so that would be this right triangle. And so if we pulled that out, it would look like this. Okay. So the slant height is actually the height of the face of the pyramid. Okay. And our theorems. The first theorem is the lateral area of a cone equals half the circumference of the base times the slant height. So we get this formula for lateral area, but notice that that reduces down to pi r L. Okay, I prefer remembering this because it reminds me of whoops, where did it go? It reminds me of where it came from. I don't know why this is acting up on me today. So it's 1/2 2 pi r times h, okay? Or times L, pi r L, okay? All right. Then we have the total area of a cone equals the lateral area plus the area of the base. So lateral area plus base area, okay? And so again, notice that we could write this as pi r L plus pi r squared, okay? And finally, the volume. The volume of a cone equals 1/3, and that's the key, 1/3 the area of the base times the height of the cone. And so we have this formula here, okay? And let's go ahead and look at one example. And so I have this cone. where 12 is the height or the altitude, 13 is the slant height, and r is the radius. And so first thing that we need to do is find r, because we know this is 12, this is 13, and this is r. This is a right triangle, so we can use Pythagorean theorem. So 12 squared plus r squared is going to equal 13 squared. Okay, so 144 plus r squared equals 169. So r squared is 25, so r is 5. So now we know the radius is 5. Now we can find lateral area, because lateral area is 1/2 the circumference, so 2 pi r, times the slant height. So 1/2 2 pi times 5 times 13. Okay, and so we get 65 pi units squared. Okay, then we can do total area. So remember, total area is the lateral area plus the base area. So lateral area was 65 pi. Base area is pi r squared, so that's pi times 5 squared. So it's 65 pi plus 25 pi, which gives us 90 pi units squared. And then volume, remember, is 1/3 the base area times the height. So base area is pi r squared, and the height is 12. And so we get 100 pi units cubed.